Understanding Intervlan routing. So in order to understand Intervlan routing, first if we come here, let's say so if you look at here 192.168.10.2, just put 10.1, and if we come here, let's make it 10.3. and make it 10.1. So this is 10.2, 192.168.10.2 and 192.168.10.3. Now if we send a packet from here to here, you see it is successful. Okay, so what happened here, what we did here is, so this is 192.168.10.2 and this is 192.168.10.3. they both are in the same network and they both are in VLAN 1, okay. So you don't need to go to the router, and you can see how the routing works in the routing video, so it will become much more clear. Okay, so if I just play this one simulation, play, so if you look at here, this is how the packet is being sent. It will not even go to the router. Okay. And he will send a reply. And if you look at here, it will be successful. You see the green, it is successful. Okay, now what we are going to do, we are going to create VLANs. Okay, now if you look at here, so you will make it 10.2 and we'll make it 20.3 and this is 20.1. Okay, once you configure, once you change the IP address, and if you try to send packet, it will no more be successful. You see here, progress failed, because they both are in different networks, and if they are in different networks, you need a router to route the traffic. However, we need to change the VLANs as well. Now let's come here. First of all, we already know what is VLAN. It's a logical networking. So device in VLAN 10 cannot communicate with VLAN 20 by default. Why we need VLANs? To improve security, for network segmentation. So VLAN is equivalent to networks from the switches perspective. And performance, like you create a smaller broadcast domain in order to improve the performance of the network. So you can create VLAN 10 for teachers, VLAN 2 for 20 for students, VLAN 30 for admins. Even if all the devices are connected to the same switch, that means you have a switch here and the switch has VLAN 10, 20, 30 and the ports are in different VLANs on the same switch, the VLANs keep them logically separate. VLANs cannot communicate with each other by default because switch operates at layer 2, VLANs are separated by broadcast domain. Now look at here very carefully, even if they are connected, PC1 VLAN 10, PC2 VLAN 20 connected on the same switch, they cannot communicate. And that is what we have just seen. They cannot communicate. What's the solution? The solution is inter-VLAN routing. What is inter-VLAN routing? Inter-VLAN routing allows traffic to move between VLANs using a layer 3 device, a router or a layer 3 switch. So important, router or a layer 3 switch. So PC1, even though they are connected to the same switch, the traffic will go to the router and the router will forward the traffic to the other PC. So if you look at here, first of all, which is a layer 3 switch? So if you come to the switch, this is a layer 3 switch. This is a layer 3 switch. Okay. Now, and what's going to happen here is, this is a VLAN. The packet previously used to go like this way, but now it will go like this way on the router. Router will process the traffic and it will come here and it will come here. Now Look, this is a legacy way of doing things. What is the legacy way of doing things? So if you look at here, we have got three VLANs: VLAN 10, VLAN 20, VLAN 30. For each VLAN, you will have a connection between the switch to the router. For example, if I just show you from here, for example, if you look at here, let's make it 20, 20.1, 20.3. Now I have one connection between the router and the switch. Let me do another connection between the router and the switch. So we do first Ethernet. Let me configure the IP address here. Let's say 192.168.1.1, and for fast Ethernet 1.0, 192.168.20.1, and make sure no shutdown. Now give some time. The spanning tree protocol on the switch is holding everything. Okay, now everything is green. Now send packet from here to here. Okay, it failed, then no problem. First 3 packets may fail. Okay, it seems like a lot of packets are failing. Now let's come here. So it's 10.2, 10.1, and I think I might have made a mistake. So it is 10.1. Okay, and here it is 20.1. Okay, now let's send a packet. Still failed. Now if you look at here, successful. Now if I play this one in the simulation, okay, first of all I will remove this one because the first one failed. Come to real time, delete. Let me send a packet. Successful. Simulation, start. It goes there. It goes there. Comes here, and it comes here. Okay, so you see the, then it will give the reply anyway. So you see the tick sign at the end. So if you look at here, in progress, and there you see successful. Okay, now try to understand here very carefully. Let us say that we have another VLAN. So we have here for 10, 20, even though I didn't create the VLANs yet. Okay, I think so. Let me have a look. Enable show VLANs. Okay, I just wanted to show you like how it works even without VLAN, but we'll come to that point later. Now look at here very carefully. Let's say if I want to do the third connection, let's say we have another VLAN 192.168.30 dot something. Try to connect. You see the ports, there are no more ports available. Now it is true that you will run out of ports, but you will have a lot of VLANs. So this solution is an old solution, and this solution is not a feasible solution at all. Okay, let's come here, let's remove this one and remove these things as well. Okay, now so if you look at here, this solution is not a feasible solution because soon you will run out of the interfaces. There will be wastage of the router ports, not scalable. Okay, it is not used. Okay, it is not used. Okay, now there is another solution which is most common, which is also called router on a stick. Okay, so what is this router on a stick? It is a very important for the exam and also for the real life. you will have one physical connection, but you will have multiple sub interfaces, and there we're gonna use 802.1q tagging. So if you look at here, we have fast Ethernet 0/0.10. It's a sub interface dividing the physical interface into multiple physical interface and put the IP address. Now in this case, if you look at here, let me come to the router CLI. Okay, let me put the commands here. So if you look at here, so I'm dividing fast Ethernet 0/0 into .10. Okay, so copy. Look, first of all, I will just make sure that the main interface does not have any the main interface does not have any conf term, any IP address, and it is in no shutdown. So if you put this command, I'll just put it here, no IP address, no shutdown, that's it. The main interface does not have any IP address, and it is in no shutdown state. Now what I'm going to do here is dividing the main interface into child interfaces. So fast Ethernet 0/0 dot, this is the parent name and you cannot change it. So here you can put 1 to any number that you want. Okay, check what it is supported. So the best practice is to put the match with the VLAN number. So I will make it 10, fast Ethernet 0/0.20 for VLAN 20, fast Ethernet 0/0.30 for VLAN 30. Okay, so if you look at here, fast Ethernet 0/0, so for VLAN 10 I will do this. Okay, let me copy the whole thing. Now what I did divide the interface into two interfaces, and I put two IP addresses. Until this we don't have any problem. I just put two IP addresses. Why two IP addresses? For two VLANs, they will be in separate networks, so I need two gateways. For this one is 10 dot network, so I need a gateway from 10 dot network. I need a gateway for 20 dot network, like 20 dots whatever is the network. However, I have only one interface, so I divided the one interface into two interfaces, and I have put two IP addresses on two interfaces. So if you look at here, if you do here, show IP interface brief. So if you look at here, fast Ethernet 0/0 is the parent interface. It doesn't have any IP address, nothing, but now it has divided into two sub interfaces, and it seems like, so if you look at here, okay, so actually I didn't remove this IP address 1.0, so that is why he couldn't get that IP address. There was an error. So if you come here, first of all remove this one 1.0. I did the wrong one here. Remove this IP address. Okay, no IP address is there. Just copy this one and put it here. Now if you do show IP interface brief. Why I'm putting here do? I putting here do because I'm doing the show command in the global configuration mode. Now if you look at here, these two interfaces have been newly created and they both have got IP addresses, and they will fulfill, one will be acting a gateway for this PC, another will be acting a gateway for this PC. Now this is one of the ways. Now look at here very carefully. The router and the switch, the connection has to be trunk. Why it has to be trunk? Because the difference between access port and trunk port, access port can carry only one VLAN, trunk port can carry multiple VLANs. The main purpose of this lab is to make sure that we are using only one interface. So only one interface has to carry all the VLANs. So it has to be trunk. It has to be trunk. Now, switch adds a VLAN tag. Okay, the tag contains the VLAN number. It can be 0 from 4094. Router reads the tag. Router sends the traffic to the correct VLAN interface. Now, when I say router reads the tag, VLAN is not a router's thing. The router doesn't understand the VLAN's language. How the router is going to read the tag? So if you look at here very carefully, here, whenever he is sending from VLAN 10, because I made this VLAN 10 and I made this VLAN 20. So router will receive for this interface, he knows that he is receiving VLAN 10 tag. He needs to know for this interface he is receiving VLAN 20 tag. So you need to tell the router that you are receiving VLAN 10's tag. Okay. Okay, based on these things, if you look at here, the command here, encapsulation.1q10, you are saying that you will receive the packets based on VLAN 10. Okay, so the router reads the tag and the tag is VLAN 10. Okay, you are telling the tags that you will receive is VLAN 10. And what kind of tagging it will be done? It will be done 802.1q tagging. There is another tagging which is ISL. This is Cisco's proprietary. However, even Cisco doesn't use it. It is little bit complex. Okay, little bit complex. So even Cisco doesn't use it. So this is the international standard. Okay, so this router reads the tag. How router reads the tag? With the help of this line, you are saying you will be receiving the tags. So if you look at here, if I take this one, based on this line, you are saying you will receiving the, you will be receiving from VLAN 10. Okay. Now, I said you don't have to match these two. You don't have to necessarily match these two. However, if you match, that's good for you because you don't need the documentation. Otherwise, you will have to read the documentation every time if there is a problem. Okay, if there is a problem, you'll have to read the documentation every time. Okay, and this IP address is same as like you put an IP address on the router interface. Now, the switch is going to use trunk. So on the switch, you need to configure switch port mode trunk. So if you come here on the switch, fast Ethernet 0/1, you need to make it trunk. Enable conf term, and you need to make it trunk. Okay, so that he can carry multiple VLANs. Okay, look, previously when we did, if you take a big, like it was successful and I showed you like it went there, it come back here, and we didn't configure anything because everything was in VLAN 1. But when you introduce VLAN, now we are introducing VLAN. So if you look at here, this is fast Ethernet 0/11 and this is 0/21, and we are 0/11 will make it 10, 0/21 will make it 20. So whenever your switch connect to an end device, they are access mode. So if you come here, okay, first you create these VLANs, and after that you make the switch port into different VLANs. So come here, that's it. And if you want to see, do show VLAN. If you look at here, 10, 20, these two ports are in two different VLANs, and you will not find these two. So you need to go and watch the VLAN video, okay, how it works. Is no more there, okay. The STP is preventing them from getting green, but once they get green, they will get green. Now, if you look at here very carefully, if I draw the whole thing one more time, this is VLAN 10. This is VLAN 20. This is trunk. This fast Ethernet 0/0.10 it will understand VLAN 10. So you did encapsulation.onQ10 and you put an IP address which is acting as a default gateway for VLAN 10, and you have fast Ethernet 0/0.20 encapsulation.1Q20 who will understand only VLAN 20, and the IP address which will work as a default gateway for VLAN 20. Okay, so this is what we have done. So let's read here. Now look at here how the router understands VLAN. So once you configure this .1Q10, that means this interface understands VLAN 10. So as I said, this doesn't have to match. So if it wants to carry VLAN 20, you can carry VLAN 20. So whatever you write, he will do, but you will have to carry the documentation. Okay. So if you put the same thing, you look at interface 20, you know that he carries VLAN 20. Okay. So that's the best practice. Okay. Otherwise, it will get your life. It will make your life very complex. Router receives the tagged frame. So look at here very carefully. 802.1Q tagging. The tagging will be done .1Q, 802.1Q tagging. The tagging will carry the VLAN number. The router receives the tagged frame, reads the VLAN ID. With the help of this command, he can read the VLAN ID, okay, and sends frame to the correct sub interface, okay. Router packet to the destination VLAN. Routes packet to the destination VLAN. Router acts as a default gateway for each VLAN. How it acts as a default gateway for each VLAN? It has got sub interfaces, and each sub interface is a default gateway. For each VLAN. Okay. Now, there is something layer 3 switch, which is a layer 3 switch. This is a layer 3 switch. The layer 3 switch by default has routing capabilities. Okay, if you write IP routing, it will start routing, and the layer 3 switch works as a switch as a router. So if you put the IP address on the VLAN interface, actually this one will work as a default gateway for VLAN 10. This one will work as a default gateway for VLAN 20, okay, and if we have VLAN 30 somewhere, this will act as a default gateway. So when you put the IP address on the VLAN interface, it automatically works as a default gateway. But of course, if this PC, you need to put the default gateway as the SVI. You see, SVI IP as the SVI IP address, whatever you put here. So this computer's default gateway will be this one. So it's the same device, it works for everything. Now if you come here and if you send packets, failed, beautiful, first few packets may fail. It also failed. Let us do some troubleshooting. So it's 10.1, it is 20.1, and let's see where we made the mistake. It's good sometimes if we make mistake, we can do. Now it is successful. So it takes some time, okay, it takes some time to get, you see, now it is successful, okay. So it's the same thing, the packet goes here. So if you just delete this one, send a packet, come to the simulation, play. It will go to the other switch. So this is the very basic of the inter-VLAN routing. I'm not discussing the advanced part of the inter-VLAN routing. That's it, successful.